In this question, we want to list the values of x for which f has a local maximum, and what are these local maxima, if they exist. So I'm looking at the graph and trying to determine if I have any local maximum. And what I'm looking for are changes in the graphs increasing and decreasing. So let's take a moment to look at this function overall and decide where the function is increasing and decreasing. So I'm going to trace the graph going from left to right. And as I trace along this section, I notice that the y values are decreasing. So let me label this section of the graph is decreasing. At this point, the y values are now increasing. And then it switches again to decreasing. And then it switches again to increasing. And then it switches one more time to decreasing. When I'm looking for a local maximum, maximum meaning highest or largest, I'm looking for the places when the graph changes from increasing to decreasing. If it changes from increasing to decreasing, it creates a peak, which is a maximum, a local maximum. And that's happening in a few places along this graph. Right here, we see a change from increasing to decreasing, which creates a local maximum. And here's another point where the graph changes from increasing to decreasing, creating that little peak. Now we notice that these two peaks are not the highest y values of the graph. We notice that all of these y values are larger. Even though they're larger, the word local is allowing us to narrow our focus to a localized area. So if we were to focus on only this portion of the graph, we notice that we do have a maximum in that localized region, and the same goes with this region here. In this localized region, we do have a maximum value. And so that's why we preface the word maximum with local. It may not be the maximum of the whole graph, but in a localized area, it's the maximum. So let's take note of the ordered pairs where we have these local maximum. This first ordered pair is -1, 1, and the second ordered pair is 3, 1. So our function has local maximum at x equals -1 and 3, and the local maximum refers to the y, the actual largest y value in that localized area, and that is 1 for both ordered pairs. So we have two localized maximum at x equals -1 and 3, and the local maxima is 1. On this question, we want to find the average rate of change for the function between the given values. The function we're working with is f of x equals x squared plus 3x. And we want to find the average rate of change from x equals 2 to x equals 7. Now the formula for average rate of change is very similar to the slope formula for a line. The average rate of change formula is f of b minus f of a over b minus a. The slope formula is y2 minus y1 over x2 minus x1. If you look at the average rate of change formula, f of b and f of a are two y values, and we're subtracting them. and then we have their associated x values in the denominator that we're subtracting. So this is very similar to the slope formula, and the main difference is that with the slope formula we're going to be using 2 points on a line, and with the average rate of change our 2 points are on this function here, which doesn't necessarily have to be a line. In our example, we're going to let A be 2 and B be 7. And we need to calculate f of B and f of A in order to be able to apply this average rate of change formula. Now, f of B is f of 7. So we'll substitute a 7 into our function f of x to get 7 squared plus 3 times 7. 7 squared is 49, 3 times 7 is 21, and 49 plus 21 would be 70. And we'll find f of a. F of a is f of 2. That's 2 squared plus 3 times 2. 2 squared is 4, 3 times 2 is 6, and 4 plus 6 is 10. Now we'll apply this average rate of change formula. F of B is 70, f of A is 10, so in the numerator we have 70 minus 10. In the denominator we have 7 minus 2, that's B minus A. So simplifying the numerator, 70 minus 10 is 60, 7 minus 2 is 5, and 5 divided into 60 would give me 12. So the average rate of change for our function f of x equals x squared plus 3x from 2 to 7 is 12. In this question, we want to do the following for the function f of x equals 3x plus 2. In part A, we express the slope of the secant line in terms of x and h. In part B, find the slope of the secant line for h equals 0.5, 0.1, 0.01 at x equals 1. What value does the slope of the secant line approach as h approaches 0? Find the equation of the secant line at x equals 1 with h equals 0.01, and graph f and the secant line found in part C on the same viewing window. So let's start with expressing the slope of the secant line in terms of x and h. I'm going to give a little background. There is a formula for slope of the secant line, but I'm going to describe where it comes from. So we'll start with a curve. So we have some curve on our graph, and the secant line is going to be a line that crosses through 2 points on our curve. So I'm going to let x be the first point, and then the second point will be a little bit further down. And we'll say that little bit further down is the amount of h. We would take 2 points on that curve that are associated with that x and h and connect them with a straight line. That straight line is the secant line. So this is the secant line. Now the y values that go with those points would be f of x for this first one here, and f of x plus h for the second one. Now we're interested in finding the slope of that secant line. We have a formula for calculating slope of a line that's y2 minus y1 over x2 minus x1. So we'll use this f of x plus h as our y2 and f of x as our y1. That will give us f of x plus h minus f of x all over, and we're going to use x plus h as our x2 and x as our x1. We have x plus h minus x. And we can simplify that denominator. I'm copying down the numerator. And the denominator, the x's would cancel, leaving me with h. So this gives us a formula for calculating the slope of the secant line. So we label that with m for slope with a subscript of SEC for secant line. So our formula for slope of the secant line is f of x plus h minus f of x over h. That's a general formula for the slope of the secant line. We want to find the slope of the secant line for our function f of x equals 3x plus 2. So I'll start off by finding f of x plus h. Everywhere I see an x, I'm going to change it to x plus h. So that becomes 3 times x plus h plus 2. And then I want to subtract f of x. Our function f of x is 3x plus 2, and notice I put parentheses around that function. And that's to make sure that this minus applies to the whole function and not just the first term. In the denominator, we have h. So I'm going to use the distributive property on this 3 and the distributive property on this negative. That will give me 3x plus 3h plus 2 minus 3x minus 2 over h. 3x minus 3x is 0. 2x minus 2, that's a 2 minus 2 is 0. And I'm left with 3h over h. The h's cancel, and I have 3. So the slope of the secant line is 3. Now the reason why the x and the y canceled out in our expression is because our function is a linear function. F of x equals 3x plus 2. If we were to use another function that wasn't a linear function, the slope of our secant line would have the variables x and h in it. So this is the answer for part A. The slope of our secant line in terms of x and h is 3. In part B, we're asked to find the slope of the secant line for h equal 0.5, 0.1, 0.01 at x equals 1. The slope of my secant line doesn't have any variables in it, so I don't have anything to substitute into. But if my function was something other than a linear function, I would have x and h within the slope of the secant line, and I would substitute the different values of h as well as the value of x to answer part B. For this example, part B will have the answer of 3 for every value of h. The slope of the secant line is 3 for all of these values of h and x. So it's 3 and 3 and 3 for all 3 of those answers. In part C, we want to find the equation of the secant line. And to find the equation of the secant line, you need the slope and a point on the line. Now we've already found the slope. That slope is 3. This is the slope of the secant line. And we have x equals 1. We need to have the y value at that point. So remember, my function is f of x equals 3x plus 2. F of 1 is 3 times 1 plus 2. That's 3 plus 2, which is 5. So this is the ordered pair that I'll use to find the equation of the secant line. The formula is y minus y1 equals m times x minus x1. We call this point slope form. And I'll substitute the slope as well as my ordered pair into this formula. That gives y minus 5 equals 3 times x minus 1. I'll use the distributive property on 3 to get 3x minus 3 and add 5, and this gives y equals 3x plus 2. Y equals 3x plus 2 is the equation of the secant line. I'm going to zoom out a little bit so we can see our question again. I want to make sure we answer all the parts. And I just noticed that I missed this part of the question right here. What value does the slope of the secant approach as h approaches 0? All of the slopes of our secant lines were 3, and so the slope of the secant line approaches 3 as h approaches 0. Finally, part D, we want to graph f and the secant line in the same window. So I have the graphing calculator right here. And our original function was y equals 3x plus 2. And the equation of the secant line is also 3x plus 2. And to graph them in the same viewing window, they are the same line. So this is a little unusual, but because the function is a linear function, the secant line is the same as the original function. And so we've answered all of the parts on this example. On this question, we're given the piecewise defined function f of x equals 5x minus 1 if negative 5 is less than or equal to x is less than or equal to 5, and x cubed minus 5 if 5 is less than x is less than or equal to 6. And what we want to do with this piecewise defined function is find f of 0, f of 1, f of 5, and f of 6. So let's start with f of 0. If we want to find f of 0, this notation indicates that x is equal to 0. And with a piecewise defined function, we're given these conditions on which to use the specific equation. So since x is 0, and 0 is in between negative 5 and positive 5, we're going to use that first equation to evaluate the function. So f of 0 is 5 times 0 minus 1 equals 0 minus 1, which is negative 1. So f of 0 equals negative 1. Then we'll find f of 1. 1 is the value of x, and just like before, 1 does lie in between negative 5 and 5. So we'll use that first equation in order to find f of 1. F of 1 is 5 times 1 minus 1. That's 5 minus 1, which is 4. So then we want to find f of 5. So x is equal to 5. And with our inequality, we have negative 5 is less than or equal to, and less than or equal to 5. So since we are equal 5, and this inequality has equal 5, positive 5 does lie within that interval, and we'll use once again that first equation. So f of 5 will equal 5 times 5 minus 1. That's 25 minus 1, which is 24. Finally, we want to find f of 6. This indicates that x equals 6, and we'll use the second inequality this time. 5 is less than 6 is less than or equal to 6. So x is equal to 6, and this inequality equals 6. So this time we'll use the second equation, x cubed minus 5. So f of 6 is 6 cubed minus 5. 6 cubed is 216, and 216 minus 5 is 211. So f of 6 is 211. For this question, we want to find the rule that describes the piecewise defined function that's in this graph. So in the graph, I can see that these two lines, even though they seem to be connected here, are very different from each other. We have a curve that looks like a parabola, and then a straight line. So that indicates to me what format our rule for the piecewise function is going to come in. It's going to be f of x equals, and since there are two pieces, there'll be two equations, and each equation has a condition that goes with that equation. So I like to start with the conditions first. The conditions are going to be conditions on x. So you want to pay attention to what x values are in each one of the lines. So looking at the straight line, the x starts at -4 and stops at -2. So x is going to be between two numbers. So we're going to write that as x being in between a -4 and a -2. And then you want to pay attention to the endpoints. So you'll notice that this endpoint at the -4 is drawn with a filled-in circle, but the endpoint with the x of -2 is drawn with an open circle. So that means that we are going to put an equal to on the -4, but not on the -2. When we draw a filled-in circle, that point is included, and the equal to in our condition tells us that that endpoint is included. When we don't put the endpoint, when we don't put the equal to, we don't include the endpoint. So this endpoint is not included. Then when we look at the other line, it starts with the same point as the other one and goes till 3. So these x values start at -2 and stop at 3. So x is in between -2 and 3. Looking at the endpoints again, this endpoint is not included, and this endpoint is. So we're going to put an equal to on the endpoint that's included. So that gives us our conditions and tells us when to use each of the equations. Then we want to figure out what are those equations. So for the line, we have 2 points that are on that line, and we should be able to find the equation of the line from those 2 points. So our 2 points are -4, 0 and -2, 4. So we're going to start off by labeling them as x1, y1 and x2, y2. We're going to find the slope, which the formula for that is y2 minus y1 over x2 minus x1. That gives 4 minus -4. No, sorry, using the wrong ones there. It's a y of 4 minus a y of 0 over an x of -2 minus an x of -4. That's 4 over -2 plus 4. 4 over 2, and 4 over 2 is 2. So now that we have the slope of the line, we can use our point slope form, y minus y1 equals m times x minus x1. And we'll substitute the slope of 2 and our point into this formula. That's y minus 0 equals 2 times x minus -4. Y minus 0 is y. And on the right-hand side, we have x minus -4, that's x plus 4. And we can distribute the 2 to get y equals 2x plus 8. So we know the equation of the line is 2x plus 8. So then we want to find the equation of this parabola. And the equation of the parabola is going to be x squared. This is our x squared graph. So that gives us our piecewise defined function. F of x equals 2x plus 8 when x is between -4 and -2, including -4, and x squared when x is in between -2 and 3, and x equals 3. Thank you for checking out my videos. Have a great day.